Hello, my name is Manuel Gomez, and today I'm going to present this project that is an isopropylic washer for 3D printed resin parts. This is a group project, and the team is constituted by Gabriel Alejandro Santamaría Pinzón, Juan Fernando Serrano Alarcón, Miguel Ángel López Jaramillo, Eduardo Santiago Martínez Arabia, and me, the person speaking. The general objective of this project is to develop a prototype of an isopropyl washing machine for the post-processing of 3D printed resin parts. In order to get to this objective, we have divided it in more little specific objectives that constitute the design, building, and validation of this prototype. The justification of this project is that 3D printed is a technology that is becoming more popular and more used in the engineering world. We every day see even more pieces made with 3D printing. In this project, we are going to focus in the resin printing. Resin printing is a technique of 3D printing that is made with the solidification of liquid resin via laser. But this method has some technical aspects that require the piece to be post processed with washing and curation of the piece. So for the washing cycle of these pieces, there are commercial washers that are specialized in this task, but these washers are usually pretty expensive. So what we are trying to do in this project is to get to a more affordable alternative for these washers. So in order to keep this project on a budget, we try to get some good but actually pretty not cheap, but may I say affordable components that could be obtained by almost everyone. These components include a plastic container, a wooden box. For the embedded system, we decided to use an Arduino Uno because this is a pretty affordable and easy to get embedded system. It's easy to program. Is very flexible with the program. We have a lot of resources, so it's very versatile for the things we wanted to do. For the motor, we decided to use a brushless motor. For the propeller, we're going to use some neodymium magnets. We are going to talk a little more about it later on in the presentation. We need a power source and well some basic circuitry components. As we need the washer to be able to be connected to a normal plug, we decided to use a power transformer from 120 to 12 volts. We use some embedded systems to keep the voltage stable, as it's going to be the source for the embedded system that is going to be the Arduino Uno, and also this power system is going to power the motor and all the circuitry that is going to be inside the washer. In the initial stage, we decided to make this CAD model to have some idea of how we were going to build this washer. So we decided to use a wooden box and some 3D printed parts to get like the functionalities we actually want, because 3D printing is a very versatile technology. We decided to use steel mesh for getting the part inside the alcohol. This steel mesh is going to be attached to the lid of the container, so it will be easy to get it down to the alcohol. This is how we expect the final result to be. So I consider this to be pretty interesting, and is the working principle of our rotor. So as you can see in this, we extracted this idea from a video we saw on internet. Use these neodymium magnets to build a submarine. As we know, like a submarine is always surrounded by water. It need to be sealed, because if the water gets in, there will be a problem, and is the same case with the washer. We don't want the alcohol to be spilled everywhere. So what we did in order to keep the alcohol in the container and not like risk the possibility of getting leaks, we decided to use these neodymium magnets that we have the motor that has its own custom rotor that has some space for the neodymium magnets, and we have another rotor that is going to be placed inside the container that has another neodymium magnet. In well, the neodymium magnets use the attraction. We use the attraction force of the neodymium magnets to make the rotor inside of the container rotate without the need of physical connection with the motor. So this is the working principle that ensures everything keeps dry. For the building process, we faced some complications related to a power source, but because at first we wanted to make like our our own custom power source, but it didn't go pretty well because we had some heating problems. So we finally decided to use a power source that was extracted from a coffee machine. So there you can see it. There is also the making of the GUI, the user interface, and also the programming of the Arduino. No, we really didn't have that much problems with the Arduino, not near with the power source. It was pretty easy to build everything, and well, at the end we get some satisfactory results. So I'm gonna show the results now. I hope you enjoyed the presentation, and see you later.